Hello, my little mathematicians. Today, I'm going to help you go through the Data and Statistics Unit Study Guide. So, as always, make sure that you try it on your own first, pause the video, and then, pause it, try it on your own, and then unpause it and check to see how you did. And you can always fast forward to just the particular one that you need help on. Okay, so the first one is you're trying to decide two things. One, is this categorical or numeric? And then two, is it statistical or non-statistical? Okay. So for the first one, it says, what is each student's favorite restaurant at my school? So numerical or categorical? What type of answers you're going to get? Yeah, those are going to be categorical. And then is that statistical or non-statistical? What did you say? Okay, you should have said that that is going to be statistical. Okay, because you're asking like enough people and you're going to be able to like make a chart or something on it. So that is a statistical question. Okay, the next one says, what size shoes do you wear? You should have said numeric or categorical. Yeah, numeric. Okay, you're going to get number answers. And is it statistical? No, because you're only asking one person. It's only one response. So always like try to answer the question. And if you only elicit one response, then you're like, oh, nope, that's not statistical. What kind of graph would that make? Not a very exciting one. And if it's a non-statistical question, try to rewrite it so that then it is statistical. So how would you rewrite that? Yeah, you could just ask like, what size shoes do the people in your family wear? Or what size shoes are all the kids in your fourth period class? Like as long as it's directed at more than one person. Okay. How many books have the students in my class read this month? Are you going to get number answers or categories? Yeah, numbers, so numeric. Is that statistical? Yes, it is. Okay. It's the next one says, how fast can the sixth graders run 1 mile? Okay, is that going to be numerical answer? Yes, it is. And then is it statistical or not, though? Are you going to get more than one response you can put into a graph? Yes. Okay. The next one, how many times do you go to PE each week? Numeric or categorical? You should have put it's numeric. And then is it statistical? No, because you're only asking one person. So you want to direct it towards like, more people. So like how many times do students in different schools go to PE each week? So as long as you like phrase it so that it's directed towards like a group of people, then it's going to end up being statistical. Okay, what is your favorite type of food? What do you think? Is that numeric or categorical? Yeah, you should have put that it's categorical. And is it statistical? No, because again, you were just asking one person. So direct it towards a group of people. Okay, the next one, okay, you have this graph right here. And you want to see, or you want to describe what's the overall shape, spread, and then what's the center of it. Okay. So what would you say? For shape, maybe that's like, is it symmetrical or is it skewed? And then the spread, like how spread out is it? What is the variability like? And then where's the center? What would you say? Okay. Hopefully you said something along the lines of, it's not symmetrical. It's not even, I can't even really say that it's skewed because it's not like all on one side and then tilted this way or all on this side and tilted that way. It's kind of all over the place, right? But there are kind of like two different centers. Like there's a center here and then there's a center here. So it's kind of an odd particular graph with two centers. And then for the spread, I would say it has a pretty big range. It goes from 35 to 75, so it has a range of 40. And yeah, so we already answered all those questions. Okay, what would you say about the next graph right here, this histogram? Okay, what's its shape, spread, and center? Okay, is it symmetrical? Is it skewed? What's the spread? Can you know the specific spread? So like this one, I could say it's exactly 40. Can I say the specific spread? No, but I can kind of generalize, right? It's from 40 to 60, so about 20, but we don't know precisely because what if like the highest number here was actually 58 and the highest one in this section was actually 44? So you can't give a specific spread from a histogram, but you can give a general idea. So I said, like, it is symmetrical because it has a center and then it goes down on either side. It's not perfectly symmetrical. Like this one isn't lined up perfectly here, but it is the general idea that here's your center and it goes down on either side. And then the center is probably most likely going to fall somewhere in here. Because like if I were to add this section here, then this size is probably the same as this. And so then when you cross off to find your middle, it'll be somewhere in that section. And then it's spread loosely from 40 to 60. So it has about a range of 20-ish, but we can't be precise like we can with the dot plot because, again, in a histogram, we don't know exactly what the beginning and end numbers are. Okay, so that was our review of, talking about overall shape and spread. Now let's get more specific with our graphs. So if we turn the page, the next thing they want us to do is they want us to look at this data set and find the mean and median. Okay, so to find the mean, what is it that you do? Yeah, you're going to add all those numbers together. Okay, so go ahead and add all those in your calculator. And when you added all of those numbers, what did you get? You should have gotten 768. And then the next step is to divide by how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So you're going to divide by 12. And when you type that in, you get a mean of, 64. Remember, the mean is the average where you add them all together and then divide by how many. Now to find the median, you want to put them in order from least to greatest, which they're not in. Okay, so my smallest number is 43, and then 44, 46, and then 52, I think is the next one. Next one I notice is 54, and then 61, 65, 71, 77. I think 81 is the next one. 86, and then 88. Okay, double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Duh, we knew that. So double check you wrote them all down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. Okay, so always double check you wrote them all down because if you didn't write all the numbers down, then you're automatically going to miss the median, aren't you? Okay, so cross off from, first, and then second, from the beginning and end. Beginning, end, beginning, end, beginning, end, beginning, end. It's between these two numbers of 61 and 65. If you can't just look at it and see what the median is, then go ahead and add those together and then divide by 2. So 61 plus 65 is 126. And when you divide that by 2, you get a median of 63. So are those close together? Yeah, those are really close together. So there's probably not much variability in the set. Okay. Let's see this one. The following data set represents the numbers of dollars 20 customers withdrew at an ATM, and they want you to find the mean and median of these. The only problem is it's not just 20, 40, 60, 80, 100, and 120. It's 20, 10 times. So you could write out, 20, 10 times. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then you have 5 40s. So 1, 2, 3, 4, 5 40s, and 2 60s, and 1 80, 2 100s, and no 120s. Okay, so that is my data set. Okay, in order to find the mean, sure, you could type all those in. I had to write it out like that to find the median because you have to cross out from beginning to end. But to find the mean, I actually wouldn't just add all that in my calculator. I would do this. I have 20 10 times. So what's 20 times 10? That's 200. So that represents all my 20s. I have 40 5 times. So what's 40 times 5? That's also 200. So instead of adding all this in your calculator, I added that section to get 200. I added this section and I got 200. and then you have two 60s, so that's 120. And then you have 180 and two 100s and 0 120s. Okay, so I can add that instead of adding that huge massive sum. That would have been hard. So when you type that into your calculator, what do you get? 2, 4, 600, and then that adds 200, so 800. And the problem is it's not 1, 2, 3, 4 numbers, right? It's all these numbers that make up that sum. So I added the frequency. That's 15, 16, 17, 18, 19, 20 numbers, okay? So when you do 800 divided by 20, you get 40. So 40 is my mean, okay? And then you know there's 20 numbers. Did I write down all 20 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Good. Before I started crossing off to find the median, let's make sure we wrote them all down. Okay, so beginning, end, 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 beginning, end. It is between that 20 and 40. Well, what's between 20 and 40? 30. If you didn't know that, add them together and divide by 2. Well, 20 plus 40 is 60, and 60 divided by 2 is 30. Okay, again, please, please, please make sure that you're trying these on your own first, like pausing the video, trying them, and then unpausing it to check yourself. And if you need to like speed it up or slow it down, you are more than welcome to. Okay, for the MAD, your first step is to find the mean. Then you find the distances from the mean, and then you take the mean of those distances. Okay, those are your 3 steps. So first step, let's go ahead and find the mean of this data set. Okay, so 1, 2, 3, 4, 5 numbers, and add those together. 11 plus 9 is 25. So you have 25 divided by 5, which is 5. Okay, so my mean is 5. And you want to find the distance that each number is from that mean. Okay, well, 5 minus 5 is 0. 6 minus 5 is 1. 5 minus 5 is 0. 5 minus 4 is 1. And 5 minus 5 is also 0. Remember that you're finding the absolute value of these, because I know 4 minus 5 is technically negative 1, but you're finding the distance, and distance is always positive. So you're taking the absolute value of those. Okay, now add those together, and you only get 2. And you take that sum, the total deviation, and you divide it by how many numbers there are, because you're finding the mean of those distances. And when you do 2 divided by 5, you get 0.4 for your MAD. Okay, so my MAD is 0.4, and we found my mean to be 5. What does the MAD represent in this situation? It's the average distance that each number of days is from the mean value of 5. Okay, and that's all there is to it. For my next set, we want to find the interquartile ranges and the quartile range. Okay, so my first step, because I'm finding the ranges, or the interquartile range, I need to find my quartile 1 and 3, so I need to find my median. So let's first of all put it in order from least to greatest. So my smallest number is 2, and then my next number is 3. My next one is 4, and then I have a 5, and then I see 2 6s, 1, 2, 3 8s, and finally a 9. Okay, double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Okay, perfect. So now I can go ahead and find the median. So beginning, end, beginning, end, beginning, end, beginning, end, beginning, end. And in the middle, it's between that 6 and 6. And so between the 6 and 6 is 6. That's my median, right? However, keep in mind that because it's between those two numbers, this 6 is part of the lower half and this 6 is part of the upper half, because they didn't actually ask me to find the median. They want me to find the Q1 and Q3. So that's the median of the bottom half. So include this 6 as part of this half. So beginning, end, and my Q1 is 4. Okay, and then when I look at the top section, again, this 6 right here on this side is part of the upper half. So beginning, end, the median of that upper half is 8. And then when you want to find your IQR, you take the upper half, the median of the upper half, minus the median of the bottom half, and so your IQR would be 4. Okay, same thing for this set. Okay, so they have all these dollar amounts rounded to the nearest dollar. Let's go ahead and find the IQR, or the interquartile range of this data set. Okay, so go ahead and put them in order from least to greatest and cross off to find the middle. All right, when you did that, you should have found a median of 14. And then you look at the bottom half, okay, and you crossed off and you found the quartile 1 to be 9. And then you crossed off to find the median of the upper half, which was quartile 3, is 21. So then your IQR is the median of the upper half minus the median of the bottom half. So what is 21 minus 9? Yeah, you should have gotten an IQR of 12. Okay. Hopefully this is getting easier and easier the more we do it. We're halfway done with our study guide. You got this. Okay, let's look at our next one. Okay, they gave me a histogram and they asked me a few questions about it. They said, Mrs. Wilson has her son Benji chart the number of minutes he reads each day during the month of June. Use the graph below to answer the questions. How many more days did he read 30 to 39 minutes than he did 0 to 9 minutes? So 30 to 39, that falls at the 12, okay? And then 0 to 9, that falls at 3. So how many more minutes did he read this many minutes than this many minutes? Well, 12 minus 3 is 9. So 9 days he read the difference there, 12 minus 3. Okay? So next one. The sum of which two intervals is equal to the number of days that Benji read 20 to 29 minutes? So if I look at this interval of 20 to 29 minutes, that is 7. Okay? So 7. Which two ranges also equal 7? So 2 together. Well, I need to find this one. That hits at 4, and that one also hits at 4. Okay, so what 2? Well, I could say the 0 to 9 and the 10 to 19, right? Okay, because 3 plus 4 is 7. And then also I could have done these two, the 0 to 9 and 40 to 49, because 3 plus 4, again, also equals 7. So either of those two intervals would work. Which interval would you say is most likely to have the median number of minutes, and why? Okay, what would you say? Okay. I said that 30 to 39, because if you add all these together, like this section, this section, this section, this section, this section, that's like the total number of days, you get 30. So halfway between 30 is 15. And so if you trace it back, here's 16, right? 4 and 12 make 16. So 15 into the data would be here. And adding this way, the 15th number would also fall in this range. So it's somewhere in that interval of 30 to 39. Okay, the last section says which two intervals account for approximately 60%? Well, first of all, you need to figure out how much 60% is, right? So 60 out of 100 is equal to how much out of our total was 30. Okay, I can't do the shortcut, but I can do cross products. 100 times x is equal to 30 times 60, so that's 18 with 2 zeros. So when you divide by 100, you get x is 18. So which two intervals together equal 18? Yeah, you should have put intervals 20 to 29 and 30 to 39, because at 20 to 29 there was 7, and at 30 to 39 there was 12, and 7 plus 12 equals, yes, it does equal 19, and we said 18, but that's why it said approximately that much, okay, because there is no two together that add to 18, but that's close enough. Okay, moving right along, aren't we? So our next one is of a box plot. And on this box plot, they're going to ask us some questions. The first one, really easy. What's the median? Your median is where? Yeah, it's always this center line of your box plot. So here the median hits at 2 lunches. Okay, the next one says half of the first graders purchased what or more lunches a week. So this is the halfway point. So this or more, 2 or more. The interquartile range of the numbers of lunches purchased each week is what? Well, the IQR, what is that measuring? Yeah, it's Q3 minus Q1. It's the top of your box, which is 3.5, minus this Q1, which is just 1. So when you subtract those, what do you get? 2.5. Okay, the fourth quartile of the first graders purchase their lunch blank times or more each week. Okay, so the fourth quartile is where? This is the first, this is the second, this is the third, this is the fourth quartile. So, so right here, they purchase this much or more. Where does that fall? Yeah, 3.5. Okay, so this is just testing to see, do you know what each of these things mean in a box and whisker plot? Okay, and now they're testing, do you know what it means when you have a dot plot? So determine the median number of hours. You could list this out, 5.5 plus 6.5, 7, 7, 7.5, 7.5. Sure, you could list it all out and cross off to find the middle, but why not just use your dot plot? So this represents a data value. So cross off beginning and end, beginning and end. Next one's a 7 and then an 11. So beginning, end, beginning, end, beginning, end, beginning, next biggest number, beginning, end, beginning, end, beginning, end. So it's between there. Oh, okay. Well, that was easy. Between 8 and 9 is, yeah, 8.5. Glad it wasn't a hard one to figure out. How do the mean and median differ? Okay, so go ahead and, oh, we skipped this one. Define the mean. That's where you're going to add 5.5, 6.5. A 7 and a 7 is 14. 7.5 times 1, 2, 3, 4. You get 30. 8 and 8 makes 16, plus a 9. 9.5 and 9.5 is 19. 10 and 10 make 20. Another 10.5. 3 11s is 33. And then an 11.5. Add all those together, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 of those data values. So when you add all those together, you should have gotten 175. And 175 divided by 20, yes, is 8.75. So how much do these differ by? Not that much. Okay, when you subtract your mean and your median, you get only 0.25 hours. Not that much at all, because your data is kind of almost a little bit symmetrical, so it's not that big of a difference. There's not like any big outliers. Okay, which number of hours slept per night was the most common? We'll just look at the peak, and your peak falls right here at 7.5. So that's the one that they slept or was the most common. That's your mode. Okay, last page. We're almost done. Okay, your range of scores, I would say, is 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. Okay, go ahead and try to tally these up. Okay, and so see where they fall and then create a histogram.